Okay, we'll just start from here. This is the last section. So if you're having a large number of data, for example in this case we have 6 data points, then you have to use fifth order polynomial. Then if you use such kind of polynomial, we'll be having very oscillatory nature. If you go much more higher, for example n equal to 11, 12, such kind of situation, then if you're having a large number of data, for example you have 20 number of data points and you are using some 11, 12 of polynomial to fit that data, then it will be having some kind of oscillatory nature especially at the endpoints. But if you are using your spline technique, then you can see that it will be much more smoother and very fine kind of interpolation, because it will take only the adjacent points. So once if you are taking, it is taking only this adjacent points. Since it is taking only these adjacent points, it does not have to consider all these points at a time. So we can directly use the cubic or quadratic type of interpolation to fit in between. Actually it will take 2 points, but because if you are using linear interpolation, you can see that linear interpolation case it will be having like these lines connecting these points. So okay, so at the node region we have some discontinuity if you are using linear interpolation technique. So we can use cubic or quadratic term in order to remove this discontinuity of the slope at the node region. So it is better to use quadratic or especially cubic. So we'll get very smooth interpolation as like this. Okay, so that's importance of using spline as compared to polynomial and as quadratic and cubic as compared to the linear interpolation techniques. Okay, and in the case of spline, we have to use this function, that is interp 1d, that is sp dot interpolate dot interp 1d, which is for interpolation, and we have to give this t and v, that is as array that we already defined in this program. So that is the available data points. Then we have to give this kind, which is linear, cubic or quadratic, whatever you can give, and accordingly it will give you the interpolation. So what is the advantage of this? The advantage of this is we don't have to calculate all these matrices and all other coefficients, etc. We don't have to calculate it. It automatically calculate by this function. So there will be a module, and all instructions are already written, and it will automatically calculate it and give you the interpolation as it is, and it will be plotted. So this is a very simple function and very powerful. So but if you are having only numpy, then you cannot do this, because this is in scipy. So you have to install scipy and you have to do that. If you are using numpy, then you have to construct this matrix and solve for coefficient and do. And in this case, this matrix method, we have only considered the case of polynomial. For if you want to consider this for spline, then you have to consider each and every adjacent two points like this. Then you have to construct all the other equations that we already discussed, and this matrix will not be like this, as you know. That will be coming in the third row, it will be coming 0 0 0 first. Okay, so there are some differences in that case, and you have to construct that matrix for a single spline. Okay, so for a single spline, so we have to construct for each and every spline different equations, and for each and every spline we will be having different coefficients, and calculate the corresponding value which spline we required, and we have to choose that. So there is some arrangement has to be given done to in these calculations if you are calculating for spline, but this is for just for polynomial, how it is to show how to do this in numpy, and how it is different in case of spline for the case of scipy. So that is what we have discussed here. I hope you understood this. Okay, thank you.